All right. So DI. There's our pen. It's writing. Aha, I knew it would do that. All right. So it says find our graph and find the domain and range, extrema intervals of increasing and decreasing. So remember, it's our absolute value function. Has a horizontal shift of -2 and a vertical shift of -3. But we're going to try and make these a little bit more accurate. Right? So we can create our XY table to plug in values. So at -2, it's -3. So we can plug in -1. If I plug in -1, -1 plus 2 is 1, 1 minus 3. If I plug in -3, -3 plus 2 is 1, 1 minus, so those are both -2. If I plug in, let's see, 0. 0 plus 2 is 2. 2 minus 3 is -1. And it's the same on that side, and so we get our absolute value function like this. And so our domain is -infinity to +infinity. Our range is going to be, it's going to start at here at -3, and it's going to go on to infinity. The extrema, I have a minimum. Now extrema is how high or how low your function is, and so the extrema, that's going to be at -3. So I have a minimum at -3. My intervals of increasing and decreasing, so it's decreasing from -infinity to -2, and increasing from -2 to infinity. And we can move on to the next one. So this next one, ooh, look at this. We have an x squared inside of there. So we need to figure out how this is going to turn out. So I don't really know. So what we should do is we should just create an XY table. And let's pick some numbers. -3, -2, -1, 0, 1, 2, and 3. So if I plug in -3, -3 squared is 9. So -3 squared is 9. 9 minus 2 is 7. 7 plus 1 is 8. So at -3, it's going to be up at 8. And then at -2, -2 squared is 4. 4 minus 2 is 2. 2 plus 1 is 3. Now at -1, this is where it's going to get a little weird. So at -1, it looks like it's going to 1. 1 minus 2 is -1, but the absolute value of 1, -1, is +1. So that's going to be 2. Interesting. It's kind of interesting what it's doing there. Okay. So now at 0, 0 minus 2, -2, absolute value -2, right? It's +2 plus 2 is 3. Interesting. Okay, so it's doing this weird down and up thing, right? That's like super kind of weird here. And then if I plugged in +1, and then if I plug in +2, and then if I plug in +3, I get those values. So it's doing this weird, like I said, it's doing this weird like bouncy thing. What is this? Okay, so what happens if I plug in a value in between here? Right? Or what if there are any zeros? I wonder if there are any zeros to this. -1, no, there's no absolute value of -1. So there aren't any zeros. So we can't do that. So it's almost as if the graph is doing this weird coming down bouncing thing, right? The question is, does it go a little lower when it does its bouncy thing? So it could do that. And the only way we can do it is, this is where we would want to look at Demos. dyslexia, we want to look at Desmos. So plug that into Desmos and see what it looks like. And that's going to give us a shape to kind of help us out a little bit more. Same thing with this one. You know, using Desmos might be helping out with us. But then the important piece here, right, is this is decreasing, then the increasing, then decreasing, and then increasing. That's what we want to look for. All right, so solving the equation, remember, isolate the absolute value. Once you do, you can break it apart into a plus or minus. So that means there's two versions. You have the positive version, and you have the negative version. And now you solve each one. So subtract x, x minus 1 equals 1. Add 1, you get x equals 2. Distribute the negative. You're going to subtract x minus 1. So negative 3x equals 0. Divide by negative 3, you get x equals 0. So now testing x and y intercepts, or so solving the x and y intercepts. Remember the x-intercept, you plug in 0 for y. For the y-intercept, you plug in 0 for x, and you solve for each one. Test for symmetry. If it's over the x-axis, you're going to replace it with a negative y. If it's over the y-axis, you're going to replace it with a negative x. The origin, it's both. Negative y and negative x.